Hi everybody, Mr. Lee here. Today we're going to go over acceleration. Much like distance, position, speed, and velocity, acceleration is also one of those words that we use in our day-to-day language, but with the physics definition, there's a couple of little nuances that we can add to your definition to have make sure that you have a better understanding of what's going on in our world. Alright, so let's start off with the definition of acceleration. Acceleration is the change in velocity. Okay, so it's just as simple as that. Now, when we say it's a change in velocity, we can get a little bit more into the details of it. It is when an object speeds up, it's when an object slows down, or, now this is a very important one because a lot of people forget about this one, but it does come up a lot. It's when an object changes direction. Okay, so acceleration technically has three different requirements. It's when an object either speeds up, slows down, or changes direction. Now, it is very, very important that you understand this next thing. Acceleration does not tell you how fast an object is moving. That is velocity. If something has a lot of acceleration, it could not be moving at all. It doesn't have to be moving fast at all. Acceleration is also a vector. So what this means is that the positive and the negative directions, it actually matters a lot, and we'll go into it. Okay. Now, one way that I usually remember acceleration is, or what I like to tell the students, is imagine a car. So when you're in a car, when you want to speed up, you push the gas pedal. Okay. You can also, if you want to slow down, there's the brakes, and if you want to change direction, there is the steering wheel. Okay. So right there, in your automobile or maybe even your bike, you have three ways of representing acceleration. Okay, so let's go into the equation for acceleration. I'm going to show you different versions of it, but like a lot of things in physics, the definition also contains the equation. So if we say that acceleration is the change in velocity, well, that's our equation. So acceleration, we represent that with the lowercase a, and because it's a vector, we're going to add that little arrow on top. Okay? It just helps us out. So acceleration is the change in velocity. Now, if you remember, the symbol that we use for change is delta, and velocity is v, the change in velocity. Now, it's not that simple because, remember, with how we live our lives, the only way we know that things are changing is if time is involved. So, simply put, the definition of acceleration, or the equation, is the change in velocity over time. Okay. Now we could break this down even more, but I want to start off with this equation here. You can see from this equation how we can come up with the units. I want to show you the two different ways that we can represent the units, and I'm going to go into both ways. So the unit for velocity is meters per second over the unit for time, which is seconds. Now, sometimes you might hear me say meters per second, and I think this is a very important way of looking at it because it shows us that we are seeing how the velocity is changing over time. Now, the more common way that you can see the units for velocity is meters per second squared, because we have 2 seconds there and they multiply together. Now, this is the go-to way of describing a object's velocity or an object's acceleration, the units. But like, to start us off, it doesn't really tell us much. You know, what does meters per second squared even mean, right? Compared to meters per second, we know that we are comparing velocity with time. Right, is how much that velocity is changing with time. But this is the go-to way of describing a object's velocity, and those are the units. Okay, so sometimes you might see this equation broken up even more. So if we know that acceleration is the change in velocity over time, we should also know the equation for velocity. right? Velocity is the displacement over time, over the change in time. Okay, let's put a little delta there. So if it's the displacement over time, that's the velocity. And we're not going to change the denominator. We're going to keep that as is. That's delta t. So right there, look what we have there. So in this form, we can see why the units can be also written as meters per second per second. Okay, so sometimes you might see the equation written this way. All right, so there are different ways of writing out the velocity. However, for our class, we will be using this equation and this unit as we move forward. All right. With the equation out of the way, and with the units and with the variables out of the way, I want to go into the nitty-gritty of acceleration. Okay, it's, even though the definition is simple, is how fast something is speeding up, how fast something is slowing down, or if it changes directions, it does get a little bit more complicated. So I'm going to go into the first two parts of the definition for acceleration: speed up and slow down. Now this is one of those things where you should definitely have it down, and I do strongly recommend that this is one of those things that you memorize. Okay, so I'm going to create a table. Okay, and let's see. In this table, we're gonna do we'll do a velocity, we'll do acceleration, and we will come up with the, let's say, what's going on. Okay, what's going on? Okay, what's happening with the object? All right. So if we have an object with a positive velocity, so all that means is that it's moving in the positive direction. And so for our example, we'll just say it's moving to the right. And there is a acceleration. It is accelerating also in the positive direction. So I want to pause right there, because this is one of those critical thinking moments. If you are moving in the positive direction and you are also accelerating, if your velocity is changing in the positive direction, we can say that you are speeding up, because your velocity is increasing in the positive direction. Okay. Now, if we have an object that is moving to the left or the negative direction, and we have a positive acceleration, okay, so we are moving to the left, yet the object is accelerating to the right. Okay, so we're moving to the left, but the object is accelerating to the right. Now, we are slowing down. Okay, all right, very important. Now, if we have an object that is not moving, zero velocity, but it has a positive acceleration, now this is very important because this is one of those tricky ones. If the object is not moving, but it is speeding up in the positive direction, at that moment, at time zero, it is at rest. Because this is very important, because the velocity actually describes the motion. Acceleration just describes to us what's going to happen as time moves on. So as time moves on, it'll go from rest and then it'll speed up in the positive direction. Okay, but at that moment, it is considered to be at rest. All right, now let's try the negative acceleration ones. Okay, if we have an object that is moving in the positive direction, but it has a negative acceleration, so the velocity is changing towards the negative direction, that means we are slowing down. If we have an object that is moving in the negative direction, and there's something that's causing it to accelerate also in the negative direction, then we say that the object is speeding up. Okay. If we have an object that is at rest, zero velocity, and it has a negative acceleration, then we say that it is still at rest. Okay, so hopefully by now you see some trends. If the direction of the velocity and the direction of the acceleration, if they are the same, then the object is speeding up. If the direction of the velocity and the direction of the acceleration are different, then that means that they are slowing down. Okay. Next In the next video, I'm going to go into the graphs of the position versus time, velocity versus time, and acceleration versus time videos. So we're going to try to wrap everything all up in a beautiful little package. Until then, I'll see you next time. Bye-bye.